So joint characteristic function of two random variables x and y is nothing but the expected value of e power j omega 1 x e power j omega 2 y. So this is called, what is that? Phi xy omega 1 omega 2. So this function is called the joint characteristic function. So that is phi xy omega 1 comma omega 2 is called the joint characteristic function. So it is nothing but the expected value of e power j omega 1 x. Okay, so it is e power j omega 1 x e power j omega 2 y, where x and y are two random variables, and here omega 1 and omega 2 are real variables. Okay, now what is the formula for this? For example, f xy of x comma y is joint probability density function of the random variables x and y. So this is joint probability density function of the random variables x and y. Okay, so then what is the formula of phi xy of omega 1 comma omega 2 will be equal to, since you have two random variables here, will be having two integrations mark. So integral minus infinity to plus infinity, integral minus infinity to plus infinity. Okay, what is the function here? E power j omega 1 x, e power j omega 2 y. Okay, f x y x comma y dx dy. Okay, now if you see this function, this is the function of two-dimensional Fourier transform. Only if the signs of omega 1 and omega 2 are reversed. Okay, so in the Fourier transform we will be having minus here, but in this function we have plus. Okay, so what is phi xy of omega 1 and omega 2 is the Fourier transform of f xy of x comma y. Here the signs of omega 1 and omega 2 should be reversed. Okay. Similarly, f xy of x comma y will be inverse Fourier transform. It will be inverse Fourier transform of the joint characteristic function. Okay. What is joint characteristic function? The joint characteristic function is two-dimensional Fourier transform of joint probability density function, whereas joint probability density function is inverse Fourier transform of the joint characteristic function. Okay, so it is e power, only here the signs of omega should be reversed here. Okay, e power j omega 1, e power minus j omega 1 x, e power minus j omega 2 y, phi xy of omega 1, omega 2, d omega 1, d omega 2. Okay, so this is the equation for fxy of x comma y. Okay, so what is fxy of x comma y is the inverse Fourier transform of the joint characteristic equation. Okay, so similarly, if x and y are the discrete random variables, if x and y are the discrete random variables, then what is the formula for phi xy of x omega 1 and omega 2 can be written like this. Okay, this is for continuous random variables. Now we are considering two discrete random variables. These are the discrete random variables. In the case of discrete random variables, phi xy of omega 1, omega 2 will be equal to, for discrete case, we will be having summation. So we will be doing summation with respect to m, summation with respect to n. Okay, m is for x, m is for x, okay, and n is for y. Okay, then here instead of probability density function, what will be having? Probability mass function. We will be having probability mass function p of x1, xn, comma yn, and similarly p of xn, comma yn will be equal to what? Summation with respect to n, summation with respect to n. Okay, here what will be having? Equal minus j omega 1 xm minus j omega 2 yn. Okay, then we'll be having phi xy of omega 1 comma omega 2. So these are the formulas we have for joint density function. Sorry, these are the formulas for the joint characteristic equation in the case of discrete random variable.